Good morning everyone. Krishna is here in our today's online news session. Today we will discuss about chemistry paper number 503. In this paper, our total 3 unit and we will start third unit chapter number 6 colorimetry. So, first of all, what is a colorimetry? Colorimetry is a technique used to determine the concentration of color compound in a solution. So, colorimetry is a technique is determine concentration of the color compound in a solution. Mainly in simply titration we not determine the concentration of color compound because is find out between endpoint, okay, and endpoint determined by coloring agent, and colorimetry is a motivative technique to determine the concentration of color compound in a solution. Colorimetry is a device used to test the concentration of solution by measuring its absorbance at a specific wavelength of light. In colorimetry technique, it means determine the concentration. Yeah, to test of concentration of solution by measuring its absorbance means in specific wavelength light determine absorbance. Then absorbance find, then concentration is also find. Or in analytical chemistry, colorimetry is a technique used to determine the concentration of color compound in sample solution at visible region. Colorimeter instrument work at a particular visible region. Okay, and visible region range is 400 nanometer to 800 nanometer. Principle of colorimetry: the color compound have a property of the absorbing the certain wavelength of light. When monochromatic light pass through them, the amount of light absorbed by solution according to two law, Lambert's and Beer's law. Mainly, colorimetry instrument is work on two law, Lambert's and Beer's law. In this case, prepare the one homogeneous absorbing medium. When we pass monochromatic light, then absorbing medium is absorb the light, and this light is depend on two law, Lambert's and Beer's law. Also, what is a photochemistry? The branch of physical chemistry deals with photochemical reaction and other chemical effect of light is called photochemistry. When some amount of light is incident on chemical or solution, okay, then the light is interact with solution or chemical substance, then photochemically change occur. This type of study related with this branch is also known as a photochemistry. Given below example, we can understand very. A plus B gives product AB in presence of H mu at a 2000 angstrom to 8000 angstrom. Is given example, A and B both are reactant. When we pass H mu light at 2000 to 8000 angstrom, when both reactant are react to each other and gives product AB. And photochemical reaction symbol is H mu. What is the EMR? Electromagnetic radiation. Different types of radiation arrange in increasing order of their wavelength and decreasing order of their energy or frequency. Okay, different types radiation is arranged in wavelength is increasing order and energy or frequency in decreasing order and form a EMR. Component of EMR: gamma ray, X-ray, UV, visible, IR and radio are a component of EMR. And particular in colorimetry we will study visible region only 400 nanometer to 700 nanometer. First we look at violet color to red color in this region, and when we move from left to right, wavelength is increased and energy or frequency is decreased, because wavelength and energy is inversely proportional and frequency or energy is frequency and energy is directly proportional. The difference between thermal and photochemical reaction. The name indicates the thermal reaction means this reaction required heat, and photochemical reaction means this type reaction required light. Okay, in case of thermal reaction, during the reaction heat may be absorbed or emitted. Okay, in reaction heat absorbed or emitted. In case of photochemical reaction, during the reaction radiation of light is absorbed. Light is absorbed in photochemical reaction. Increase the temperature, rate of reaction is also increases. Rate is directly proportional to temperature, because according to Arrhenius theory, Arrhenius says that temperature is directly proportional to rate of reaction, because in system number of molecules are present, then temperature is applied and molecules are collide to each other, then kinetic energy is increased, kinetic energy is increased, and also rate of reaction also increases. In photochemical reaction is temperature independent, because first point say that photochemical reaction is required only and only light, so it is a temperature independent. In case of thermal reaction, reaction is a spontaneous reaction, therefore delta G is a negative. In natural reaction is always spontaneous reaction. Spontaneous reaction always delta G is a negative. For a photochemical reaction, value of change of gift-free energy is may be positive or negative, because photochemical reaction require light. If light is not present, then reaction is a non-spontaneous. Non-spontaneous reaction have a delta Z is always positive, and spontaneous reaction have a delta Z is always negative. Delta Z is negative means reaction is a spontaneous or equilibrium. In case of thermal reaction, energy is a continuous, because temperature is always increased and energy is also continuous. In case of photochemical reaction, energy is a form of packets. Okay, you know Einstein law is give, or according to Einstein law, E is equal to NhM, and N is indicate that number of photon. Okay, so in case of photochemical reaction, energy is a form of packets. Then law of photochemistry. Photochemistry, there are two laws. First law of photochemistry is given by Grother-Stropper's law and is also known as a photochemical activation. It states that only that light which is absorbed by a system can bring about photochemical change. Okay, only that light which is absorbed, it can bring about photochemical change. Let's take one example. Consider one atom, and this atom is given externally energy or light in form of light. Then this atom is in ground state, then atom is absorb energy and is go from excited state, means this type of system is photochemical change by absorb the light. Then the second law of photochemistry is given by Einstein photochemical equivalent, and this states that according to this law only one molecule excited by one photon excited only and only one molecule. Then light absorbance law. First law, Lambert's law. When beam of monochromatic light passes through a homogeneous absorbing medium, then the decrease the rate of intensity of radiation and thickness of the absorbing medium is directly proportional to intensity of incident radiation. So first, what means of monochromatic light? Beam of monochromatic light means one types of color light is called monochromatic light. When we pass monochromatic light in absorbing medium, and means of homogeneous means one or same type of phase is called homogeneous absorbing medium. when we pass monochromatic light in this medium, then the rate decrease. What is the rate? The intensity and thickness rate are decreased is directly proportional to intensity of initial या तो incident radiation. The rate decrease minus di upon dx is equal to k into I. Okay, where negative sign is indicate decrease the rate of intensity radiation per change of thickness of medium. K is a proportionality constant. When we take some one example, suppose four sample A, sample B, sample C and D. Sample A have a water and all sample A, B, C and D all have a water, and all sample have a same concentration but their path length are different. It show very well in figure. Monochromatic light, concentration C and path length L. Okay, so I have a four sample A, B, C and D all have a same concentration, but when we move from A to sample D, path length is increases. Okay, when we pass monochromatic light from sample A is absorb 5% of only and only 5% light. Okay, then we pass monochromatic light when sample B, then sample B have path length is more compared to sample A. Then sample B is absorb monochromatic light 10% because their path length is in more than sample A. Okay, then sample C have a path length more than compared to sample A and sample B. When we pass monochromatic light in sample C absorb 35% light. When we pass monochromatic light in sample D, and sample D have a path length is more compared to sample A, B and C. Okay, so when light absorbed by sample D is a 90%. So we can say that when path length is increased, also increase absorbance. So Lamberts also say that absorbance is directly proportional to thickness or path length of the medium. Also Beer law, when a beam of monochromatic light passes through a homogeneous absorbing solution, then the decrease the rate of intensity of radiation and thickness of the absorbing solution is directly proportional to the intensity of incident radiation and concentration of the solution. Okay, when Lamberts say that homogeneous absorbing medium and Beer say homogeneous absorbing solution. Okay, all law are state are same. When we pass when we pass monochromatic light on homogeneous medium, the rate are decreased, whose rate the intensity per thickness is increased and intensity is decreased is directly proportional to intensity and concentration is given by Beer. Okay, and second statement, absorbance is directly proportional to the concentration of the solution. When Lambert said absorbance is directly proportional to the path length of the medium. Okay, when we understand by some example, suppose sample A, sample B, sample C and sample D. Okay, sample A have a water, sample B have a petrol, sample C fill up by diesel and sample D is filled by soil. Okay, when we pass monochromatic light from sample A because water, and also suppose all sample have a same path length, but when we move from A to D, their concentration is increases. Okay, water, petrol, diesel and soil. When first sample, when we pass monochromatic light from sample A, Then sample A is light absorb only and only 5%. Okay, when we pass monochromatic light from sample B have a petrol, so that have a they have a concentration is more compared to sample A or water. Okay, when monochromatic light absorbed by sample B or petrol is 25%. Okay, because they have a concentration is more compared to water. When we pass monochromatic light or incident monochromatic light from sample C, diesel. Okay, then diesel have a concentration is more compared to water and petrol. Then monochromatic light absorbed by sample C or diesel is 75%. Okay, because they have a concentration is more. Then we pass sample D monochromatic light. Then sample D have a soil. Its concentration is more compared to other sample. Then soil is absorbed by light is a 90%. Okay, when we move from A to D, water to soil, concentration is increased, also increase absorbance is given by Beer. Absorbance is directly proportional to the concentration of the solution. Then combine these two laws, Lambert's and Beer's, is also known as Beer-Lambert's law. The law was first developed by Pierre Berger before 1729. It was later attributed to John Heinrich Lambert, who cited Berger's finding. The law includes path length as a variable that affects absorbance is said by Lambert's. The path length is affect the absorbance. But later, Beer extended in 1852 the law to include the concentration of the solution. Also included by Beer, the absorbance is also affected by concentration. Okay, thus giving the law its name Beer-Lambert's law. Then we discuss definition and equation. The Beer-Lambert law states that the quantity of light absorbed by substance dissolved in a fully transmitted solvent is directly proportional to the concentration of the substance and path length of the light through the solution. Okay, light quantities of light absorbed by substance is directly proportional to concentration of the substance and path length of the solution. Clear? Then we can understand mathematically form. Mathematically it can be expressed as minus di upon dx proportional to I is equation number 1. Okay, where minus di upon dx is a small decrease minus di is a small decreases in intensity of light upon passing through a small distance dx, where di is a change is small amount or decrease in small amount, where dx is a small distance and I is the intensity of monochromatic light just before entering the medium. I is the intensity, incident intensity or initial intensity before the passing into medium. Equation 1 may be written as a where proportionality symbol is removed. Then equation 1 may be written as minus di upon dx is equal to a into I is equation number 2, where minus di upon dx is the rate of decreases of intensity with thickness dx. Okay, and a is called absorbance coefficient. Then integration of equation 2 after rearrangement. Okay, same term are taken one side. So equation 2 is rearrangement. Minus di upon I is equal to dx into a. Okay, so minus di upon I, this integration is minus ln I is equal to dx નું integration થશે ax plus c, where C is an integration constant. Okay, when we pass monochromatic light from a medium, okay, where medium is thickness, starting thickness is x0 and starting intensity is the I0. Okay, where C is a constant of integration at x is equal to 0, I is equal to I0, so C is equal to minus ln I0. Put this value x is equal to 0 and I is equal to I0 in equation 3. So we can get C is equal to minus ln I0. Okay. So this value C is put in equation 3. So we can get equation 4. Okay. Ln I upon I0 is equal to minus A into x. Clear? Equation 4 can also be written in exponential form. Equation 5 is a exponential form. Equation 5 can also be written as a log I upon I0 is equal to minus A upon 2.303 into x. Okay, ln is removed, then log 10. ln is equal to 2.303 log 10 I upon I0 is equal to A upon A into x. Okay, equation 6 or equation 7 is log I upon I0 is equal to minus A dash into x. Okay, A dash is equal to A upon 2.303 and A dash is also known as the extension coefficient. And remember that extension coefficient and absorbance. So absorbance is capital A is the absorbance and small a is the extension coefficient. Okay, so absorbance is equal to minus ln I upon I0 and also transmittance is equal to I0 upon I. So clear? Where A dash is equal to A upon 2.303 is called extension coefficient and minus ln I upon I0 is termed as absorbance of the medium. Absorbance is represented by capital A. Then Lambert's law was extended by Beer, who saw that when light passes through solution of the given thickness of the fraction of incident light absorbed is depend not only on the intensity I of light but also on the concentration C of the solution. This is known as a Beer's law. Okay, you know about Beer's statement. It said that absorbance is directly proportional to the concentration. Then mathematical form that minus di upon dx is directly proportional to the concentration. Okay, so combine these two law, Lambert's and Beer's. Lambert says this absorbance is directly proportional to path length and Beer says that absorbance is directly proportional to the concentration. So minus di upon dx proportional to I into C. Then proportionality symbol is removed. Then proportionality constant is B. Okay, so equation 9 is minus di upon dx is equal to B into I into C, where concentration in the form of mole per liter, B is called molar absorbance coefficient. Okay, thank you.